Hey guys, thanks for coming to the next section of the videos for the homework. Let me go ahead and erase some of the work from the first video over here on the calculator. I jumped down to the word problems. I did skip a few problems, but I really feel confident that there's so much in the last video that you guys should be able to complete the ones that I skipped. I do want to do some of the word problems because there's some advice that's a little bit different from the advice you usually get for a word problem. For most word problems, they ask the teachers will tell you it's just a strategy: read, underline, then draw a picture and solve. You know what we're going to do? And I promise you, I haven't even read these in a few days. I'm doing them right now from scratch. Here's what I'm going to do. Create a little room to work. Before we read this, we're going to draw a picture. And you know what that picture is going to be? It's going to be a triangle. Now, this is a little bit of a trick because we know that this quiz is about right triangles. Obviously, if this was like an end of the year test, you don't know that it's right triangle trig until you read the problem. But look, we're just going to draw a picture first. Draw a picture first. It's going to be a triangle. The quiz is not about squares, the quiz is not about circles, the quiz is not about trapezoids. It's about triangles. All right, so let's get started. From the top of a tower, the angle of depression to a stake on the ground is 72 degrees. So let's go ahead and circle that. We got a number here, and we know it's an angle. The top of the tower is 80 feet above the ground. So that doesn't sound like an angle, that sounds like a side, so let's make that a different color. How far is the stake from the foot of the tower? Show your work. Okay. And then this right here, the last thing, that's going to be like our question. Right? How far is, that's going to be our x. All right. Let's go ahead and start taking some of these values that we've circled and figure out where they belong in the picture. That angle, I remember some key words. From the top of a tower. Now, if I looked at this picture, I don't think this would be the top of a tower. I don't think this would be the top of a tower. I think a tower is probably this. The top of the tower is probably up here. And so if the angle is from the top of the tower, I'm thinking that 62 degrees belongs there. If we look at our next thing, which is the blue thing, the top of the tower is 80 feet above the ground. So when I think above the ground, I don't think this direction. In fact, I don't even think this direction. I think 80 feet above the ground is this. This is the tower. This is the tower. This is 80. They're just describing how tall the tower is. So we know that side is 80. And then the last question is, how far is the stake from the foot of the tower? So the stake, if we go back and read that first sentence, what they're saying is, from the top of the tower, the angle of depression from the top to the stake is, oh, I'm so sorry. This is supposed to be 72 degrees. Not sure what's wrong with me. But anyhow, the stake from that 72 degree angle, so they're not describing this direction, they're describing this direction. So here's our stake. In other words, if they want to know how far the stake is from the foot, that means our x is going to be down here. So our angle is up here, our given side is here, and then how far from the stake to the tower, that's going to be to the foot of the tower. Right? That's another thing. The foot of the tower is not up here, so there's no way this problem would be the hypotenuse. Foot means bottom, so from here to here. All right, if we look at our values, we have 72. This x here is actually opposite from the 72, and the 80 is adjacent to the 72. So this is going to be a tangent question. Tangent 72 equals opposite over adjacent, so x over 80. And if you've watched the last video, I showed you guys that you can save some steps and also improve the accuracy of your answer by just typing in 80 tan 72 instead of converting tan 72 to a decimal. Because then you're going to round, oops, we need tan 72. So if you type 80 tan 72, that will take 80 and multiply by whatever tan 72 is. And the calculator knows the complete value, not just the rounded value, so you get the most accurate possible answer. Sorry, I don't know why I spaced out here. I was worried for a second that this number didn't feel right, but I think it's fine. All right. So that's that question. We drew a picture first. When we do the next problem, we're going to draw a picture first. Then we're going to read and we're going to copy those values into the picture. Let's make a little blank space. So we'll have some room to work up here. We'll have some room to work down here. And before we even read this question, let's just go ahead and say we know that our triangle is going to be up here somewhere. And look, we can draw these any different way. So let's say we got a triangle. Yeah, we can draw it this direction. It'll be fine. To guard against a fall, a ladder should make an angle of 75 degrees or less with the ground. I'm pretty sure ground is down here. Ground would not be up here. So I'm pretty sure we can go ahead and call this 75 as our angle. What is the maximum height that a 20-foot ladder can reach safely? So the ladder is 20 feet. If you think about what a ladder would look like, this is the ground, this is the wall, and this is the ladder leaning against the wall. So if the ladder is 20 feet, we know that that's 20. And then when it says maximum height, height means straight up and down. So find the maximum height means find this side of the triangle. So let's go through and let's label, let's figure out our work. This is the longest side of the triangle, so this is definitely hypotenuse. If 75 is here and we go across that triangle, we see that this is our opposite. And so since this is an opposite hypotenuse question, it's a SO, sine opposite hypotenuse. So let's come down here and do our work. Sine 75 equals h for height over 20. And once again, to solve this, we're going to multiply by 20. You do not have to convert sine 75 to a decimal. I did that the first few days. I really wanted you guys to do that because I wanted you to understand that it's not the number 75. It's whatever this number is. I just wanted it to be clear that sine 75 does not mean 75. It means some other value. So that's why it was so important for me that we wrote this down the first few days. But we also know that it's important to be accurate. So the best way to do this is not to write it down as a decimal and then type it back in. The most accurate way to do this is to say 20 sine 75 and get a value. Looks like our answer for the height is going to be 19.319. Now we did round, but we rounded as the last step. We rounded to 3 decimal places, so we have a very accurate rounded answer. All right, that's that. Let's do the third word problem. Make a little room to work. And let's go ahead and draw our picture, because this problem is going to be about right triangles. And let's draw the triangle this way. I don't think it matters too much. I know that's not the best looking right triangle, but let's say that the right angle is right there. Yeah. According to parking standards in Santa Clara, an access ramp, so if we look at these sides, I'm pretty sure this is a ramp. An access ramp to a parking lot cannot have a slope exceeding 11. Suppose a parking lot is 10 feet above the road, so above. That's a straight up and down thing. I think this is 10. If the length of the ramp is 60, does this access ramp meet the requirements of the code? So here's something I should point out. There's a number in the question that we're not using, which is the 11. What this question is really saying is, think about it this way. If you had a handicapped ramp, let's say you were building a ramp for someone with a wheelchair, you would not have a problem with a handicapped person maybe rolling their wheelchair up something that was this steep. That's probably okay. I know, but if you built a ramp and the ramp was this steep, this would probably be a ridiculous thing for someone in a wheelchair to try to roll up. I'm pretty sure it's impossible. This would be fine. This would be probably just pretty normal ramp in a parking lot or in a store for handicapped access. This would be ridiculous. So what we're trying to do here is they're trying to just say find the angle. And if the angle is big, then it's a problem. If the angle is small, it's not a problem. And 11 is just what we're going to use to separate big from small. So what we're really going to do is we're going to find this angle. And if the answer is bigger than 11, then this is not a fair ramp. If the answer is smaller than 11, then this is a fair ramp. Obviously, based on how I've drawn it, this is probably a little too steep. But obviously, this picture is not very accurate. That's why it's important to find the value. So let's do some labeling. We look across, we got an opposite. We have a sine. We have a hypotenuse. So once again, we have a sine problem, we have a so. If we set it up, we're going to say that sine x equals 10 over 60. It's perfectly fine to reduce that fraction. It's not actually required for this question, but it probably looks good to say that 10 over 60 is 1 over 6. And this is one of those cases where our goal is to solve for x. So we have to undo the sign. And in math, you undo things using the opposite. So the opposite is going to be x equals sine inverse of 1 over 6. It's important to know that it's not 1 over 6 times sine inverse, that the operation is inverse sine of. That's how you perform the operation. Similar to performing square root of. You don't multiply by square root, you do square root of. All right, so let's figure out how big that ramp is and if it's too big. So let's figure out the inverse sine. I'm going to press that second button. 1 divided by 6, or you can type 10 divided by 60. Oops, what you cannot do is type 1 divided by 60. 1 divided by 6. Hey, and look at this. The angle is pretty small. Our angle is only 9.5 degrees. 9.560 degrees. So what we're saying is it's fine, right? This ramp is not too steep. If we did the work and we got 20 degrees as the answer, this would be a no. But does this meet the code? Heck yes, it does. All right, that's the end of this video. I think I'm going to do one more video real quick for the multiple choice. Hope these help. Remember, there's still a couple of problems that you need to do that were not in the video.